Alright, question number 7. Which of the following is a representation of the general equation for the electron affinity ion J with charge of X? Well, let's start off real quick with the with my little thing that I do. So LE LE for left, RI for right. So the electron's on the left when you're talking about electron affinity, and it's on the right when you're talking about ionization energy. So we're talking about electron affinity, so we know it's going to be on the left. So nope. So it's between this one and this one. So the next thing I'm going to check is the charges. X plus 1, X minus 1. X plus 1, negative, and then X. So if you add up these charges, let's just plug in a random number for X. We'll say 2 plus 1, that's the first part, plus negative 1 equals 2 minus 1. Well, 3 plus negative 1 does not equal 1, right? Whereas this, if we use the same numbers, 2 plus 1 is 3, plus negative 1 equals 2. Add that up, check, it's true. It's going to be D. That's one way to check it. Number 8. So this one right here takes just a little bit of thought in it. First thing you're going to be using is Coulomb's law. It's not equals, it's F is proportional to Q1 Q2 over D squared. Put it on the spot, D squared. So in this point, they're asking for the distance, which would be your D, between two charges. So this would be Q1, this would be Q2. An attractive force between them the same as, that's where it requires a little bit of thinking right here. So if we're talking about the same as, we know that Q1, Q2 over D squared 1, distance 1, which is what we're going to be solving for, is going to be equal to Q3, Q4 over D2 squared. Now in this, we're given a distance. This is Q3, and this is Q4. We'll use those as Q1 and Q2. So first thing I'm going to do is get this by itself. So basically I'm multiplying by this, Q3, Q4 over 1 on both sides. And I'm also multiplying by D1 squared. Right? So doing that step, I'll get Q1, Q2 over Q3, Q4 equals D1 squared over D2 squared. So now we're going to multiply by D2 squared on both sides, and we will get D1 squared equals D2 squared times Q1, Q2 over Q3, Q4. This is all just algebra. Square root of everything, because we just want to solve for D1. So D1 equals D2 times the square root of Q1, Q2, Q3, Q4. All right, now we're just going to plug in our numbers. Pay attention though, they want it in pico. They, as I say they, me, I want it in picometers. You can do this one or two ways. I'm just gonna do it at the end. Why not? Okay, so let's plug in. We're given D1. Let me grab my pocket test. Okay. Or we're solving for D1, so it's gonna equal, I'm gonna do it over here. D2, which is 2.06 times 10 to the negative 2 angstroms. And that's going to be multiplied by the square root of positive 2.95 times negative 2.06 over positive 4.16 times negative 2.01. And then, since we know we're going to picometers, I'll take this whole thing here, just to save myself a step, do it all on the calculator. 1 angstrom, 10 to the negative 10 meters, times 1 meter is 10 to the pico, what is it, 12? Yes, 10 to the 12 picometers. If you do all of this math, let's check our units. Angstroms, cancel. In the end, you should get A, which is 1.76 picometers. Should be right in there. You have 3 sig figs on everything. You really honestly don't need to worry about the charges. You just need to make sure that they're all, like, that they cancel out. So a negative divided by a negative is going to be a positive. But yeah, so 1.76 picometers. That's A. Number 7 or 8. 8 is A, yes. Okay. Number 9. Which of the following elements would have similar properties? This is a faster problem. Alright. Similar properties. We're going to be going to check out this part of it right here. That's the part that matters, right? We're going to check out stuff in the highest principal quantum numbers. We have 5s2, 5p5. So we're looking for NP5. So this ends in S1, nope. Oh, look at that right there. 2p5, let's check the other stuff. Ends in 4p4, oh, super long, and ends in 6p3, nope. 1s, or 2s1, that's what, sodium, I think. Anyways, B would be your answer there, because it's going to have the same properties. It's going to be in the same group, which, by the way, this group is group 7A, which is also known as the halogens, right? It has 7 valence electrons, 5, 6, 7. Okay, so another quick question, and they all get pretty easy from here. Which of the following is named incorrectly? So dinitrogen oxide, that's between 2 nonmetals, right? So it's a molecular bond, so we'll be using the prefixes. Dinitrogen oxide, dinitrogen monoxide, both are good. So okay, phosphoric acid. So phosphoric is phosphate, right? PHOS fate, which is PO43 minus. So that's right? Because I ate it and it was ick. So that's 8 to ick. So check. Nitric acid, Nitric would be nitrate. NO3 minus, nitrate. Yep, check. Perchlorate ion. So ClO minus, hypochlorite. ClO2 minus, chlorite. ClO3 minus, chlorate. ClO4 minus, perchlorate. Perchlorate ion. Beautiful. Trisodium phosphate. Now, this is between a metal and a not a non-metal, a polyatomic. So, we do not use prefixes. So, this would just be called sodium phosphate. So, that's your answer, E. All right, another 10-minute video. Awesome. Okay, written by in decreasing order by size of atomic radius. So we know poorly drawn periodic table. Going down this way is your increasing, right? So that means if you're going left to right, increasing size, top to bottom, increasing. So if you look at beryllium, magnesium, and barium, periodic table. So beryllium is period 2, group 2. Magnesium is period 3, group 2. And beryllium, or barium, I don't know why I said beryllium. That is period 1, 2, 3, 4, 5, 6. Group 2. So they're all in group 2, but as you go down, it increases, right? We went decreasing, and this is going in increasing order. This would be the smallest, this would be the largest. So for this one, all of these, and actually on both of these, all of these are what is, no, I lied, that's not on C. All of these ones right here, though, are isoelectronic, meaning they all have the same electron configuration. In this case, it's all the same as neon. So now we're going to pay attention to protons. So nitrogen has 7, oxygen has 8, and fluorine has 9, neon has 10. So we're going to pay attention to how many of those have. Not only that, we're going to pay attention to the fact that it's gaining electrons. If it gains electrons, it gets bigger. So, really big, kind of big, still kind of big, and then small. Right? And that's decreasing order. This would be your largest, and this would be your smallest. So the answer is B. But looking at this would be your smallest here, right? It's lost the most electrons. And then this, and then this, and then this. Okay, so that's how you do that part. Bear with me, guys.